Hello friends, today we will discuss about the vibration. What is vibration? Vibration is the motion of a particle or a body which oscillates about a position of equilibrium. Basically to and fro motion, that is simple harmonic motion, is one kind of is due to vibration. Most vibration in machines and structure are undesirable due to increased stresses and energy. So in everyday life there are a lot of vibrations in train, in car, in machines, in ships. Everywhere we feel the vibration in the machineries. Mechanical vibration is a phenomena whereby oscillations occurs about an equilibrium point. Oscillations may be periodic, such as motion of pendulum, simple pendulum, compound pendulum, as the movement of tires on a gravel roads also have vibrations. It is may be periodic, may not be periodic or non-periodic. Vibration is undesirable, wasting energy and creating unwanted sound and noise. These are the scopes of the vibrations. By the use of vibration, we can use the vibration energy as equipment in sieve sakers, in concrete, in RCC. And harmful vibrations are noise, distractions, wear, fatigue. So scope of vibration is to reduce the vibration and use the vibration, and unwanted, undesirable may be reduced. Type of vibration. There are basically two types of vibrations: free vibration and forced vibrations. Free vibrations occurs when a mechanical system is set off with an initial input and then allowed to vibrate freely. Means we are providing initial displacement or initial force to the system, then due to this initial force the body vibrates about its equilibrium point. And forced vibration is when a time varying disturbance is applied to the mechanical system. If there is a uniform load is applied to the system, then due to that force body or system vibrates, and this is called forced vibration. This is the major classification of vibration. Free vibration: if the external force is removed after giving an initial displacement to the system, then the system vibrates on its own due to internal elastic forces, such that the type of vibration known as free vibration. As in the simple pendulum or in a compound pendulum, it is observed, and the frequency of this vibration is called natural frequency or free frequency, and denoted by Fn. It is measured in hertz. Third one, that is torsional vibration, when the particles of the bar or disc get alternative twisting and untwisting on the account of vibrating motion of the suspended body. It is called torsional vibration, and torsional stresses are produced due to torsional vibration. So in longitudinal vibration, compressive tensile stresses; in transverse vibration, bending stresses are produced; in torsional vibration, due to twisting, torsional stresses are produced. Other classification is undamped or damped vibration. Undamped vibration: if there is no dissipation of energy, energy will not lost. However, small damping has critical importance when analyzing system at or near resonance. There is no any damping. Damping means damping force. Damping force was xv. Cx dot was damping force. So damping force, there is no damping force, and therefore it is known as undamped vibration. There is no damping, there is no any C damping coefficient, and damped free vibration, will be damping force Cx dot will be there. Spring mass system, x is the displacement in the system, so x is the single degree of freedom. In torsional system, theta is the degree of freedom. So 1 degree of freedom in A, B and C. So these are single degree of freedom systems. If there are two variables required to describe a system, in figure A, x1 and x2 are two variables. In figure B, theta 1 and theta 2 are two variables. In figure C, x and theta are two variables which describe the system. So it is 2 degree of freedom system. In this slide, 3 springs are added, and x1, x2 and x3 are the displacement provided to the system. So the degree of freedom of this system is 3. In figure B, it is L1, L2 and L3. 3 pendulums are connected. Then theta 1, theta 2 and theta 3 are the 3 variables. Theta 1, theta 2 and theta 3 are 3 variables which describe the system. Therefore, 3 degree of system. And similarly in figure C, it is also 3 degree of freedom system. Similarly, if there are n number of freedom system, that is called multi-degree of freedom system. Some systems have 0 flexibility, fixed point, as freezing point is fixed point, so it is 0 degree of freedom system. Some bridge of hanging bridge has infinite number of degree of freedom system. The bridge has infinite degree of freedom system. Fixed point has 0 degree of freedom system. In our syllabus, single degree of freedom systems are mainly in the scope of subject. Now, simple harmonic motion of a free particles. If in the spring mass system, when the spring is going up and down, then it will create a sinusoidal wave, as we have seen in the simple harmonic motion. The x is the amplitude of the system, t is the time period, omega and the angular velocity of the system. So the x is the displacement vector. It is given as x sine omega t plus 5. X is amplitude, sine wave. The simplest form of periodic motion, pure sinusoidal motion, Scotiac mechanism rotating with angular velocity, is a simple harmonic motion. The displacement vector is given by x sine omega t plus 5, and time period is 2 pi by omega n, and frequency omega n by 2 pi, natural frequency of the system omega n by 2 pi. It is again shown in this picture. X is the displacement vector, velocity vector will be differentiation of this x vector. It will give you the x omega n sine omega t plus 5 plus 90. Differentiation of x is cos. So x omega cos omega t plus 5, it can be written as in the form of sine, when omega t plus 5 plus 90 is added in the system. We can see in this graph, x displacement vector is x sine omega t, and 90 forward to this is velocity vector, and acceleration vector, it is again 90 forward to this velocity vector. The differentiation of this velocity will give us the acceleration. So the minus x omega square sine omega t plus 5 is our acceleration vector, or it can also be written as x omega square sine omega t plus 5 plus pi. So the displacement vector is x sine omega t, velocity vector is 90 forward to this, and acceleration vector is 90 forward to velocity, or 180 forward from x. and amplitude calculated from this. We can calculate the angle and amplitude. Thank you very much.